So, solar cells are PN junction diodes. They are semiconductor devices, PN junction that convert light into electricity. And it can be any light, but since we usually tend to use sunlight because it is available in abundance, we call them solar cells. And you probably know where these are used. For example, we have a lot of applications for you. Probably you use them in calculators. There are solar panels at your houses, and they are also used in space probes in outer space. They are one of the best ways to generate electricity in outer space. So these solar panels, what you can see, they have solar cells on it. But how do they work? Well, at the heart of a solar cell is a PN junction. So let's quickly recap. We have seen that a PN junction is basically a single semiconducting crystal on which one side it is doped acceptor impurities, so they accept electrons, and as a result they leave behind holes, a lot of holes. And on the other side we have donor impurities. They donate electron, so they leave electrons, and the region in between is where electrons and hole destroy each other, causing a depletion region. This depletion region acts like a barrier, and it does not allow further diffusion of and recombination of electron and holes. But the question now is, what would happen if you were to shine light over here? What happens if we shine light on our solar cell? Well, let's go to our band structure to understand what happens. If you look at the band structure of a semiconductor and if you look at it near the depletion region, and we will see why we are talking about it in the depletion region, because there are no charge carriers over here. We know that a valence band must be completely full. There are no holes over here, and the conduction band must be absolutely empty. No electrons over here, so there are no charge carriers over here at all in the depletion region. But when the light falls over here, and if the light photons has sufficient energy, okay, if it has energy more than the band gap, then some of these electrons can absorb that energy and use that to jump into the conduction band.
Now, when this happens outside of the depletion region, when the electron hole pairs are formed outside of the depletion region, immediately the electron will recombine with that hole and we will release that energy back so that the process would be useless. We do not get any electric generation because of that. However, when that happens inside the depletion region, that's when things get interesting. So imagine an electron hole pair is formed inside the depletion region. Let's say this is an electron and this is the hole that is formed due to sunlight, due to the photon. Okay. Now, before they have a chance to recombine, look at this electron. This electron gets attracted by this positive charge and therefore it gets accelerated in this direction. This hole similarly is attracted by this negative charge, or you can say it's repelled by this positive charge and gets accelerated this way. So, before they have a chance to recombine, they are swept across. Due to the field in the depletion region, this is the electric field generating depletion region. As a result, when electron hole pairs are formed over, here the holes will get accumulated, they'll get swept, and they get accumulated in the p type. And when the holes get accumulated over, here are a lot of positives get accumulated over here, so the p type tends to become positively charged. And if you want to really think in terms of electron, you might say, hey, holes are not even real things, right? So what's happening over here? Well, think of it this way. Holes are absence of electrons, so electrons are being removed from this side, and when you remove electrons from a side, you end up with positive charge. Similarly, electrons are getting accelerated over here and they get piled up over here. And as electrons get piled up over here, this side becomes negative charge, and so this point gets negative charge. And now notice a voltage is generated between these two sides. And this is how in solar cell we use light to generate voltage. And that's what we call the photovoltaic cell effect. Okay. So photovoltaic cell. Yeah, the name makes sense, right? We are using photons to generate voltage, photovoltaic effect. And now, what would happen if I were to put a metallic contact over here?
And the connected device, let's say a bulb. Well, these electrons will all repel each other and immediately start flowing through the circuit, through the bulb, and will recombine with the holes. So electrons will continuously recombine with the holes, and as that happens, more electron hole pairs are generated, and more electron and holes get accumulated over here. So notice there will be a constant current supplied by this bulb and will glow. And notice this current does not have a battery. The PN junction itself acts like a battery. Wow, that's really cool. So now we will summarize a solar cell quickly.